Hello everyone. So this video is about the concept of a nested for loop. If you watched the last video, I just went over the basics of setting up a single for loop. And if you need to refer back to that, check out the previous video. You don't technically need to see that in order to completely understand what's going on here, but it's highly recommended. I'm going to start up with just a real condensed overview of what a for loop does, so that way we can understand what the nested for loop is doing. All right, so I have the online P5 code editor here. I have actually a link to this code right now in the video description, so you can check this out afterwards if you want to explore a little bit on your own. What I'm going to do first is I'm going to make a for loop. I only want this to happen once, so I'm just going to run it in the setup function for now, just to kind of show again what these do. Just real basic. So type out for, then you get your parentheses and your braces. And then just as a reminder, what you need in the parentheses of your for loop is just a real basic three things. These three things I think make sense once you know what for loops do. But if you've never worked with them before, the formatting might look a little weird. The first thing you have to do is make a variable. All right, so I'm going to say let I, and you have to assign that a starting value. So I'm going to start it at 0. This is a fairly common thing in for loops of just assigning your variable 0 to start with. Start at 0, end at some point. It's also fairly common to make the letters for your variable names just be one simple character. It's basically the variable will only exist inside of the for loop, so you don't have to make it something unique as you're doing this. So, making your variables elsewhere in your code, you have to, give them descriptive names so you know what's going on. But again, this for loop is only going to exist for a little while, and it's not going to be talking to other things, normally speaking. So, just having a little I here for a counter, totally fine. We aren't going to need to make that a super long descriptive name. Unlike a lot of things, we're going to be separating this with a semicolon. Just so you know, these are technically three little commands that we're giving the for loop, so we're separating them out with semicolons instead of commas, like we have in our other functions. So I have that there. The next thing we're going to type is a test for when to stop the for loop. So we'll say that for as long as I is less than, I'll say less than or equal to 10. All right, so this, just like a conditional, is a Boolean statement. It's basically the for loop is going to start and it's going to run until this statement we type in the middle here is no longer true. So I is going to start at 0, and we're going to run whatever code we type in the braces here until I is no longer less than or equal to 10. So in order to make that so that eventually I will be greater than 10, we need to affect I in some way. Otherwise, 0 is always going to be less than or equal to 10. Your for loop is going to run forever and ever and ever and essentially lock up your code. So I'm just going to say I++. We're going to increase I by 1. And in fact, I mentioned potentially locking up your code forever. Just as a reminder, I always recommend when working with for loops in P5 to turn off this auto refresh button right here. Essentially what this will do is just whenever you make a change to your code, it's going to reinitialize the code you've typed. And if you've accidentally made a typo in your for loop, or you may not be quite done typing it, if you pause for long enough, your computer will try to run the code, and it could potentially, like I said, lock up your code forever. And the only solution would be to go in and close out the code. You may even have to close out the whole browser, depending on how your computer is set up. It varies from computer to computer, but at the very least, you have to close out the tab, and that will you'll lose all your work from the last time you saved. So to avoid that, I just unclick the auto refresh box. You just have to then manually hit that refresh button every time. All right, so now we have our basic for loop. It will run. So basically what it's going to do is it's going to make variable I and assign it the value 0. It's going to check and see, is I less than or equal to 10? It's going to say yes and do whatever code we type in the braces here. And then it's going to increase I by 1 at the end of that loop. It's then going to check again, is I going to be less than or equal to 10? If it's yes, it runs the loop again, and then it increases I by 1 again at the end of that. Let's look at that just real quick here. So I'm just going to say console.log I. All right? And that's what we're going to do whenever we run this code. I'm going to bring the console up because we'll need some space to see everything. So if I just run the code, boom. So this happens right at the front in setup before anything else. That's why I put it there. I'll bring this up a little bit more. So we have that there. So we're console.logging I. So I starts at 0. That's the only thing in the loop. So we then increase I by 1. Check to see if it's less than or equal to 10. It is, so we console.log the current value of I, and so on and so on. So you see, every time this loop repeats itself, we get a number here displayed in the console. If we wanted to see something visually appear, we could say line, let's just say, let's say 100 comma I times 50 comma 300 comma I times 50 again. I just picked some values here. Let's see what this looks like. We run it again. This is my goof. I have covered up our results with the background. Let's try that one more time. Boom. So now I've got this happening here. I've got our vertical series of lines as we go. Again, so if you want to see whatever your for loop is doing, essentially it'll just repeat the same code again and again. And if you utilize the variable that you make in your first command here in the parentheses, if you utilize this variable in your results in some way, you'll be able to then see the process of this for loop visually on your screen. In this case, it usually involves affecting it by a number. In my case, by multiplying it by something, you get the most useful results, generally speaking. But you could affect this with any kind of math that you want. And there's just a lot of things that you can do. Technically speaking, there are 1, 2, 3, 4, 5, 6, 7. If I made this taller and reran it, there we are. We can see all of the lines now. So again, this stops when the for loop stops, and we're just affecting these really basic numbers right here. So that's all that is. But what happens when we nest a for loop inside of itself? Well, see, I'm glad you asked, because that's the topic of this video. Let's remove that, and let's do exactly that. We'll say another for. That gets its own set of parentheses and braces. And let's do that. We'll say let j. We'll assign this 0 as well. I'm going to say j. We're going to run this for as long as j is less than or equal to, let's say, 5. Oh, no, I'll leave this just as less than 5, not less than or equal to. Doesn't make much of a difference. We just don't include 5 in the final result. And we'll also say j gets increased by 1. You'll notice that I have picked a different letter for this inner for loop that we've nested. I did mention before that the variables only exist inside of the for loop. However, this inner for loop is running inside of the outer for loop, so I still exists. So you cannot have the same variable for both for loops if you're nesting them inside of each other. It won't work. At the kind of worst case scenario, your computer will try to refer to the same variable for both loops, and it will end horribly. Most code editors I've found, if this happens, it will come up with an error and it'll stop the code from running if this happens. So if I was to say I here on line 5, the code just would not run. All right, so let's start off with the console again, because I think that's a good way to see this. So we'll say console.log. And what we're going to do, we'll say, string, outer loop. We'll say plus, and then that'll be whatever value I is. And then we'll put a space, plus, forgot my plus here, plus, actually we can just put the space here, plus inner loop space plus j. So now we can see all of this going on. So one way I like to think about this is think of your for loops kind of like a programmable robot that you've created. And you're saying, hey, robot, do this thing, this task, this whatever you've typed in the results, do this, for as long as, I tell you to. In this case, do it 11 times. 11. All right, and then when you're done, stop. All right, and that's the case. So that's a single for loop. In the case of the the nested for loop, it's kind of like your robot has created its own robot to do a task. So if you're the kind of the robot master, you'd say, hey, robot I, tell robot J to do some stuff and report back to me. And then robot I says, hey, robot J, do your thing 5 times and report back to me. It'll do the console.log, it'll report back, and then the outer loop will run again, and then it'll tell the inner loop to run 5 more times, and then the outer loop will run 1 more time, causing the inner loop to run 5 more times, and so on and so on. Let's look at that a little bit visually. I think that'll make some more sense. So if I run the code, we get this. And actually, let's make this a much shorter number. Let's make this 3, just for the sake of seeing it a little bit easier in the console. Okay, so we have this here. So what's going on, like I said, this outer loop is going to run once, and then the inner loop is going to do all of its code. So we see that this is for as long as outer loop is 0, inner loop runs 0, 1, 2, 3, 4. And then outer loop changes to 1. Inner loop goes 0, 1, 2, 3, 4. Outer loop goes to 2, 0, 1, 2, 3, 4. And then the outer loop stops because 3 is no longer less than 3. So everything stops. So that's what happens when you nest these inside of each other. You get essentially an exponential growth of the amount of actions that you have here. And you can utilize these values in order to create what I think are some fairly complex and interesting graphics relatively easy. All right, so let's go in and let's make just a really basic graphic here. And in fact, I'm just going to remove draw. We'll do this all in setup today. Let's use this same for loop for now. But let's say we'll make a rectangle. So let's change some of this. Let's say fill, and I'll just make this a red rectangle. So we have that. Fill that there, and let's say we'll set this at I. Where is it? Times 50. J times 50. And we'll make these, I don't know, 25 by 25. Just kind of picking some numbers there. Oop, that's not a times. That's a times. All right. So now we run this, and boom. So I think we can see this a little bit better graphically, what's going on. So we have our outer loop. All right, this outer loop says it runs at times 0. So we have says our outer loop says, hey, inner loop, loop J. I want you to display the stuff in the console like before, but then you're also going to set this fill and draw a rectangle using I and J. Well, the first time it's 0, but the inner loop is going to run its code these 4 times right here, or I guess 5 times, 0, 1, 2, 3, and 4. So we get 0 for that first value, and then we multiply, when it runs again, we get 50, 100, 150, 200, and so on. So we get these multiple instances of this rectangle. And then the outer loop moves on to the next instance and says, hey, inner loop, run your code 5 times and do it. It does its thing, and then we get the final instance. In this case, if I was to bump this up to 10, run it again, we get many more instances of the loop. If I was to make this a little bit bigger, we can see all of them on the screen now. So this is a very quick way to get a large repeating pattern. In fact, if I wanted to make a really simple checkerboard, let's see. I think we can go about doing this. This be times 25 and 25. Now let's put that back at 50. I'm just going to try and live code this and, not that, 50. We'll put that back there. So then let's let's go another one. Let's say fill nothing, make this black, rect, starting off the same, but let's take this and offset things just a bit. I'm trying to think. Oh, say plus 20 plus 25 plus 25. Oop, we've got a bit of an issue. From my copying and pasting. Alright, so now we're starting to get there. We got this kind of repeated checkerboard pattern. Seeing this, we can again set up these very complex repeated patterns over and over again, just with some slight lines. I've just kind of I have the same line here. I've just changed the fill and shifted it over and down by 25. If I just wanted to shift it over, I could remove that plus 25, run it again, and now we get this kind of alternating pattern right here. So you can play around with this just a little bit. In fact, let me think. Let me just try to think about how we can go about doing a nested for. Let's tell you what. Let's use two different nested for loops and actually make a checkerboard. So if we go to here, this is the end of our first for loop, this outer level one. We can go in and actually let's make our lives easy. Let's just copy and paste. Boom, we got that. All right, I'm gonna remove this console.log line. Just because I'll leave this one commented here. So I've got that going on there. 15 times 50. Let's see. Let's put this one again back at 0, but then let's do all the offsetting of this one. Plus 25. Plus 25. Run it. Alright, so we've got this. Let's see. What if we condense this to make them only 25 apart? Just trying to go. I want to avoid those kind of white spaces in the middle. Alright, and that's what I thought would happen. We get these kind of blocks as we go here and here. So let's say if I change this to 50, 50, we get those spread out. And then I'll just put this back to 50 as well. Let's see. So we get this one and this one. So the goal is to, again, have these be alternating. We may need multiple for loops just for the way I'm looking at this. Tell you what, let's pull up another version of this rather than just trying it on the fly and wasting everyone's time. Let's go in and run this. So that's how I did it. I see. All right. This is another way to go about and do it. We're going to just work with some of the assets that are built into P5 to begin with. So this is how I went and did it a few years back. So I'm going to set the background to white, and we're going to use these white spaces as our code. And actually, you know what? Let's keep the red. I like the red here, so we'll say 0, 0. We'll still keep the red here, but we'll set this fill to 0. All right. I just think the red and black looks nice. So we've got pretty much almost the same thing going on here. What we're gonna be doing, I'll tell you what. Since these can be anything, let's go in. I just want to illustrate this a little bit better for teaching purposes. We can say for this will be the X position, this outer loop, and the inner loop will control the Y position. Just the way we got that set up. You just have to change all of these X, Y, Y, X. There we go. Change that there. Just so we can kind of tell them apart. We're gonna keep this up with the sizes here, but let's go ahead and add some more iterations of this. So we can go in and say, let's run this for as long as this is less than the width, because this is the width. And the inner loop will run for as long as it is the height. So we can do this and we'll get plenty of instances that I still have I and J here. Y, I, or X. And this is going to run. It's going to be a lot going on at the moment. That's okay. But what we're going to do is adjust this ever so slightly. Theoretically, you can kind of see the outlines of this. This for loop is going on a long time. So we're essentially there's 800 pixels by 800 pixels. This loop is running. The outer loop is running 800 times. The inner loop is running 800 times 800. A lot of times. So let's go in and let's just affect this a little bit, and we'll say plus equals go by 50 and plus equals 50. So that way it's essentially we're skipping every value here. So we're instead of multiplying the values by 50 in the results, we're just jumping up by 50 in the for loop. If we run that, you get this essentially the same thing. I think it's just a little bit easier to understand. We're now jumping 50 by 50. Now, let's go in and let's do essentially the same thing. I'll leave this as I and J just to tell them apart, but if we set this up to be width 50 50, height, leave that there. That can technically we don't need that fill, but we can leave it there, and then just leave this as I and J. At the moment, it's going to be identical. So let's think about this. If we run this, oh, there we are. If we run this, we're going to get essentially the same loops on top of each other. So we have two instances of these right on top of each other. So if we take one and shift it over and down, that will achieve what we want. So if we instead go in and change this to, let me say, equals 25 and 25 to start with, and rerun it, boom, we've now taken that first one, they were overlapped, and by shifting it over by a square size and down by a square size, it has created this kind of repeating checkerboard pattern over and over again. Just using, again, two nested for loops. I'm sure there are plenty of other ways to go about this. It's up to you. You can kind of explore and figure out what you want to do, how you can achieve these things. This is just a relatively quick way, again, just using the fact that with a for loop, you're making a variable, giving it a starting value, running it for an amount, and then affecting that variable by some other number. And then you're just going to keep repeating the process of whatever you type here inside of your for loop until this middle thing is no longer true. Remember, you want this to be true to begin with. Same with your inner loops, because the loop will stop as soon as the middle statement is false. As soon as that's false, the whole loop stops. So if you make something where, let's see, so if I did something like this, where x is greater than width, well, x starts as 0. Our width is 800, is defined in create canvas. So 0 is automatically less than the width. 0 is less than 800. That's a fact. You can't argue that in any way. The computers are extremely literal. So because of that, the loop will just never start. It's going to automatically start as false, and it'll just run on. So again, if you have that as something that is false and not true to begin with, you're not going to run it. If you have it as something that is true, but it will, never be false, then the loop is going to run forever and lock up your computer because it's going to be continually executing this loop. So if I was to go in and say, subtract it by 50, or we're going to start at 0 and then negative 50, negative 100, negative, and so on, it's going to keep getting smaller. It's never going to get bigger than 800. So it's going to loop on forever and ever, and every time your computer tries to run that loop, it's going to freeze up. So again, that's why I want to have that auto refresh going. So I hope this is just kind of a real kind of basic introduction to the idea of a nested for loop. Again, we have our outer loop running for every iteration of every individual iteration of the outer loop. I wanted to highlight that here. And my auto refresh got ticked on. So for every iteration of this outer loop, the inner loop is going to run in its entirety. So in this particular case, we'll get an exponential growth of everything here. So I'll make this slightly smaller. So again, the outer loop runs once. The inner loop is going to run 10 times. In fact, if I wanted to get that exact number, so we have all of this. So 1, 2, 3, 4, 5, 6, 7, 8. So for every time the outer loop runs, the inner loop is going to run 8 times. And that's going to, in this case, it's going to generate kind of a vertical column of rectangles. It's going to shift over, do it again and again for as many times as that outer loop is designated to run. Yeah, so we have that all right there. If you have any questions, feel free to drop a comment in the video, and I will explore them and answer them as we go. If you can think of a more effective way to create a kind of checkerboard pattern, I'd love to explore that and see how we can do. Again, I just kind of threw the original version of this together a few years back, just starting to kind of create some of the content for this. So I'm sure that there are many better ways when I'm not trying to make them up on the fly. So again, that kind of wraps this up. So everyone have a great